Good day, or good evening, or good morning, whatever it is that you're watching here. So I'm going to go over chapter 11 and just kind of talk about some of the things that you'll be dealing with in chapter 11. And before I get started, I want to apologize. I have a little bit of a sinus infection, so I'm going to be snorting and sneezing and carrying on. So let's talk utilities. Utilities are the things that's coming into this house or the things coming out of the house. So we have a municipal water valve coming in and comes into the house here. And then we have a sewer line that's coming out and into the septic tank, the distribution box, and into the lines. So first of all, let's talk about how a septic tank works. And septic tank. So in a septic tank, we have a couple of things that happen. Let me find one's a little bigger. It's a little bigger, but I want that. There, that's a nice one there. No, it's not a nice one. I don't like it. Yeah, that one's okay. Okay, so we generally have two containers inside of a septic tank. And in this case, we have the waste that comes in from the house, and it gets dumped into here. And we have scum, which is generally floating material, floating debris. Could be paper, could be waste, any kind of things that could be in here. The sludge is what is starting to decay. So in this first portion here, a bacterial growth is going on, or a bacterial breakdown, should I say, is going on. We have all kinds of bacteria in here that's eating this scum and this sludge up, and as they eat it up, they poop out smaller particles. And then it gets eaten again, and then it keeps on going and going and going until it's almost nothing, like water. Brown water, black water, that would go into this sanitary tea. Notice that it doesn't catch water from the top, because even in this section here, we're still going to have some particles that might float into the other side, and we don't want any kind of solid particles coming out of this portion here. So what happens is it goes into the septic, goes into the septic tank, and goes into the secondary tank, and then out into the drain, into the leach field. So into the leach field, we have just water. That's all we want, is just water coming into this. This particular one is showing a little filter on there. That generally does not happen. Generally, we just have this pipe that goes into the leach field or drain field. So in the old days, let me go up here in septic drain field. So in a septic drain field, we have something that looks like this. And a lot of times these lines here are based on how many bedrooms you got. So generally 100 feet per bedroom. That can be broken down into 50s. It could be broken down into 75s. It could be depending on the size of your lot. And the health department will be the ones to tell you where this is going and where the well will be going. So it could be 3 separate ditches like this. It could be an open ditch like this, or it could be a Quonset hut looking thing like this. I'm trying to think the name of these things, and I always forget. Nevertheless, using these devices here, we can lessen the amount of lines needed in a house. So generally, these are considered like a 85% Reduction, this is 100%. Okay, so we're going to have 100 foot of lines per bedroom. Over here, we're going to have 85 feet per bedroom of lines. Chamber system. I knew it would come to me eventually. The chamber system. This is a chamber system here. And the chamber system has basically just come into new. This is kind of old. We've had it. We've been doing this for years and years and years and years and years. And the chamber system doesn't have to have any gravel. This is all washed gravel. This is a perforated pipe, 4-inch perforated pipe that sits in here with the holes pointed down. And this particular one, this is open under here. There's nothing at all in here. Nothing. So we just basically dig our ditch, and these chamber systems go together however long we need to have them, and they're level. So this is level as well. Both of these are level. This is filled full of gravel and has a silt screen on the top of it. This is just a great big old piece of plastic, hard plastic, and these have an end cap on them, and they set in, and then we just cover them with dirt, both of them. This system here in the old days usually was about 18 to 24 inches by 3 feet wide, and then however long, like I say, generally as a rule of thumb, it was 100 feet per bedroom. So you can Google this as well and look at some different type of systems through here. So back to our packet here. You can see our septic tank, our distribution box. Oh, I was going to show you a distribution box. So let me go find that. So the distribution box is nothing more than a little box where we have the inlet pipe coming in, and the inlet pipe is going to be higher than the outlet pipes. And then the outlet pipes are all going to be dead level. And I'm not kidding you when I tell you this. The health department will come in, they will pour water into this thing until it fills up to these pipes. And then they'll take a dropper with some red food coloring or something in it, and they will watch as the water goes into each one of these little pipes evenly. And if they don't, then they will make you change this system. Now, there is a device. Oh, here it is. There's a device that you can put over these, and you can dial them in. So you can actually turn these devices so that the holes, all the way across through here, are going to be exactly the same height, so that water runs out of each of these pipes equally. That's the big thing. Now, these little these concrete boxes come with knockouts or cutouts in here, and that's what this is. So we basically take our knife out and we cut this out, stick our pipe through, and then stick this, I think it's called an easy level or an easy flow or something. It's something easy. I know, I do remember that, because without it, you really got to work at it to try to, you got to move the box, you got to do this and that, and other things to try to get the water to come out of these pipes equally. So these little devices here are great. So these are our distribution lines that we were just talking about. And down here, let's see, I passed it. Down here is a cross section of the drain tile or drain field detail. So we're basically cutting through one of these and we're looking down it, and that's what we're going to see. 4-inch perforated pipe, 1/16 of an inch pitch. That means it is 1/16 per foot, 1/16 of an inch per foot of slope in this thing. So it's almost none. When I put mine in, they wanted them level. They did not. They didn't want any pitch on them at all. So then we have, it says here crushed stone, but this is a misconception. This should be called washed stone. This needs to be washed stone. And then we have a fabric filter that goes over the top of the silt filter. Now they're saying that it's going to be 18 to 30 inches. Now, in one of the questions that I'm asking you, I'm saying let's say that there is an 18-inch average of depth of gravel here, and that's just the gravel. That's not the dirt, not counting the dirt. Just the gravel is 18 inches. So to figure out how many tons we need, we first got to find out how many cubic feet we have, and then we have 18 inches times 3 feet times the total length of all of these lines coming out through here, and then we're going to divide that by 27. Okay, because there's 27. It's 3 feet per yard, so 3 times 3 times 3, 3 times 3 is 9. 9 times 3 is 27. So it's like a Rubik's Cube. So we're going to have we're going to have 27. We're going to divide what our cubic feet, total cubic feet is by 27 cubic feet per cubic yard. Well, that cancels out the cubic feet, and that leaves us with cubic yards. Now, if you look at the question, it asks, so it says that there's 1.24 tons in gravel, stone weight, 1.24 tons per cubic yard. Well, once you find out how many cubic yards you get, then you're going to divide that cubic yardage by 1.25 to add, and that will tell you how many tons you get. So back over here, it also tells us, it asks us what the rise is. So let me kind of go over here and explain rise to you. So if we have a slope, and we know that, that our house is over here. Here's our house, and then up here is our septic tank. Septic tank is a little bit wonky. So we're going to have a line that's going to go down into the ground here, or, it's going to be pretty much kind of like that, but below ground. Okay. And then we're going to, in this particular case, it's going to run uphill. So we have to actually put a pump in here. There's a pump, a sump pump, that's going to be put into the basement. It's going to have a grinder pump on it. A grinder pump means that it just churns everything up and makes it into small particles, and it's going to pump it uphill. Now there's also a check valve in here. So let me show you what a check valve is. 4-inch check valve. PVC. Okay, so this is what a check valve looks like. And it just goes in the line, and there's a ball in here. Let me see if I can find a picture. Here we go. Well, okay, in this case, it's not a ball. It's a flapper. Okay, so sometimes there's a ball in there. Sometimes there's a flapper. So this little flapper, if the water's running in this direction, the flappers are going to open. When the water tries to run back, the flapper's going to close, and there's not going to be any water going in there at all. I don't see one with the ball on it. That one's got a flapper. But take my word for it, they do have them with balls. They got flappers and they got balls. I don't see it. Anyway, so that keeps the water from running back down into the house. So it's only going to be pumped up. So there's, this line through here is going to stay full all the time, because the check valve is generally put in right here somewhere, right before or right after the sump pump. So in this case, what we're talking about is the rise. The house is asking for the rise. So we have a pipe here that's coming out, and it's called the invert. We have a pipe going in here, and it's called the inlet. And the outlet pipe is going to be lower than the inlet pipe, but we want to know the total rise. So when we look at rise, we're looking at a perfectly, and get right here in just a second. We're looking at exactly how much rise is coming from this line out to there. So we're wanting to know this distance from here to there. So that is the rise, the total rise. This from basically from here to there would be the total length, but one of the questions is what is the rise? So you're going to look at the plan and you're going to try to find the invert and the inlet valve, and you're going to have to do some math there. Okay, so another question is asking, well, how much line do we need from point A to point B? So we're going to go back over here, and you can do a couple of things. This particular plan is 20 feet for 1 inch, which if you've got an architectural scale, you can count the inches, okay? So you can measure the inches and then multiply each inch by 20 feet. And so you can measure this from here up through here and then turn that and measure that right there to find that out. Now, if you don't have a scale, get you a piece of paper and put it on the plan and mark off this 50 foot on the piece of paper. Then find approximate center, and if you make a mark on there, well, that's going to be 25. If you do if you do 5 equal lines between the center point and down here, then you're breaking that up. Let me print this screen here, and we'll go over to here. So if basically if I cut this in half, I have 25 feet from here to there and 25 feet from here to there. But then if I break this up into 5 equal spaces, and I don't think I'm going to get it. 1, 2, 3, 4. Now, let's try that again. 1, 2, 3, 4, 5. There you go. 5, 10, 15, 20, 25. So now on your piece of paper, you can move this from here to there, and you can test this to find out how far it is. You can test this to find out how far it is, and you can test this to find out how far it is. So this is a real quick and easy scale. And if you need to, you can go in here and break one of these up by 5s. So, you can make it in feet if you want to get that picky about it. But if you have an inch scale, inch architectural scale, again, find out how many inches you got in the 16ths. And put it into a fraction. So if you've got 3/4, so 3/4 is going to be 6/8, or it's going to be 12/16. So 12 divided by 16 is 0.75. You knew that because 3 divided by 4 is also 0.75. But let's say if you have 15/16, then that's going to be 0.9375. So if I have 3.9375 inches and I multiply that by 20, then it's going to be 78 feet or 78.75 feet. That's where you're going to put the answer in by decimals, not by inches. So again, you measure that out and you come up with a number, say 3.9875. Multiply that by 20 feet, and that will give you the number of feet to this scale that you will need a 4-inch pipe to go from the house foundation to the thing here. Hold on just a minute. I need to pause this just for a second. Okay, sorry about that. Wife come in and needed me to answer a question. So let's think about this pipe work when we're talking about concrete. Let me go back over to Google for a minute here, and let's look up. Don't move the dog, Mama. Let's look up plumbing rough-in. So this is not plumbing rough. This is kind of a plumbing rough-in. So we're getting ready to pour a slab here, And so we want to get all of our plumbing that's going to go in under the slab in before we do any concrete work, because once it's in, we're screwed. We can't. It's kind of hard. You would have to bust this back out to get it to go in. So so that was what that would look like. So you kind of got to get a plan for it. Here's another one. Kind of got a figure for it. This is going to be a toilet at this point. And then notice that this is above the, or kind of above the gravel here, and then we're going deeper as we go out. We have to maintain a 1/4 inch per foot of slope minimum. Actually, they say that's ideal. If we have more, then the water outruns the waste. If we have less, then the water will not push the waste down the pipe. Here's another view as well. Actually, this is where they busted it out and had to put it back in there. So yeah. So if you have, if you do it wrong, this is what you get to do. You get to bust it out and put it back in. So try to get all of that done beforehand. One thing to note, if you're pouring the footings, I always, if I have a pipe that I know is going to go through the footing, I will put a larger diameter pipe in, such as a 6-inch pipe or a 4-inch pipe, just through the footing. Let me see if I can find something on that. Through footing. Let's see if we show any pictures here of this. Pretty much not. So here's something similar. So I have a larger pipe that's going to go through the footing, and then I'm going to feed a smaller pipe through that. Well, that allows, if there's any settling in the slab or in the footings at all, then I'm not going to end up with a broken pipe there. So I've got a little bit of play, and I can put some foam in here after it's all said and done, and allow that to seal up to where I don't have to worry about. As a matter of fact, right there where there's a picture of it. So we have a pass-through pipe, and then we have a smaller one going into it, and then a gasket or caulk or great stuff or so forth like that. And it's not a bad idea to do the same thing under the slab as well, because you're going to have this settling down, and you want to protect those pipes. So let's see what else. Oh, how do we know where to put the pipes? So we're going to go to the basement plan. We don't have to worry about the first floor unless there's anything that's underground, but this is a crawl space. This is a crawl space. We don't have to worry a whole lot about putting stuff in here, even though we need to get it to wherever it's going to come out of the house over here in this point. It's going to come out over here somewhere. I'm not going to tell you where. That's one of the questions. I want you to tell me where it is. Where does it come out at? So the only thing that we really got to worry about in this basement is the shower, the water closet, and possibly the lavatory. We could go over and connect into a riser. So there's going to be a pipe in here that that's going to go up through the roof. So there'll be a pipe. Generally, they try to always put it behind the toilet, and but let's look at what's above this toilet here. So what we have here is another toilet. So one of the things that we have to worry about here is a wet vent, because we have a stacked toilet. So let's look up wet vent. See what we got a picture of here. Okay, so here we have what we consider a wet vent, even though this is not two toilets. We have water that's coming out through here, and we've got to get air out of here. So because every time we put water into the septic tank, we need to replace that with air. And so in this case, we could have water flowing down this pipe at the same time that we have air going back up. Now, ignore these numbers here, because these numbers are completely wrong. If we have a 3-inch waste line going out, we're going to have a 3-inch pipe that goes all the way up through this to the ceiling. If if this was a toilet, both this pipe and that pipe has to be a 4-inch pipe because it would be a wet vent. Let me see if I can find another picture. Don't really see one of stacked toilets, but I think you get the gist of it. Let's see. Let me just do wet vent for stacked water closets. Still not coming up with what I want. So we'll just, here we go. There we go. So here we have the wet vent going down, and this is still not a very good example. Can't seem to find a good example. Nah, you'll just have to take my word for it. I can't seem to find what I'm looking for. But nevertheless, I think you get the gist of it. So anytime you have one toilet on top of another, you're going to have to go with a 4-inch pipe rather than a 3-inch pipe. So just stick that in your pipe and smoke it, and you'll do well. Anytime you go down with this, then you're going to have some problems. The inspector really wants to see a 4-inch pipe when you have stacked toilets. Otherwise, take for instance, we have these over here. Can they go to the same one? Probably. It's possible. There is a maximum distance of about 8 feet in which you can travel through here. So remember that the more things that you put onto this vent, then the more possibility of having a problem with too much water going down the pipe. And so in this case, it would probably almost be better to put another pipe here and run the lavatory and the water closet off of this pipe, have a pipe here, and of course this tub shower can run off of either one of these pipes here. Now these can tie together once they get into the attic, but I don't believe this house has an attic, so it would just have to be 2 separate pipes going through the roof. So let me look over here again, see if there's anything else that I need to talk about. Excuse me. Most all of these should be found pretty much on either the basement plan, the site plan, or this little detail here. So let me go back over here and check it one more time. Or in the book. Sometimes there may be some of these questions in the book. And I believe I have covered about everything that really needs to be covered there. So again, if you have any questions whatsoever, you know what to do. You need to text me. Don't wait on it. Don't say, I don't know how to do it. Don't give up. Don't skip it. Don't even wait till class begins. Go ahead and text me so that I can go ahead and help you through this, and you can understand it. So for now, so long. This is Chapter 11. Thank you.